And we're live. Here we go. 2.4. Yeah, this is where it gets good. And I'll add. Oh, my pen died. Rates of change. We've kind of already talked about some of this stuff. You got it. Well, we're going to start, so they can wait. First thing we're talking about, we've kind of already talked about some of these ideas in the very first day we started limits. Remember we were doing like average speed versus instantaneous velocity? That was just to get the whole idea of a limit going. Remember that? The difference between average speed and instantaneous speed?
Yeah.
It's coming back right now. Except that we were talking about speed, it was just more of in context. Now we're going to talk about just in terms of like a function or a graph. It's like the average rate of change for a graph. Rate of
It's easier to learn things when you're here.
Makes sense. So I could say like, and this is the first example here, but if you have a function x to the third minus x, you could ask find the average rate of change over the interval. What do you think that means? How are we going to find an average rate of change over an interval?
Difference of y over difference of x?
Yeah, there it is. It's like slope. It's like, but it's not slope because this isn't a line. I don't know what this looks like. Probably some squiggly thingy. Well, you know, it's going to go like this.
Difference of y over difference of x?
Let's just look at a little picture here. Yep, it's a squiggly thingy. So it doesn't have a slope. Only lines have slopes. But we could find like the average slope between 2 points. So that's what this is saying. Over the interval 1, 3. So from when x is 1 to when x is 3, what's the average slope of that curve? Does that make sense? So you kind of draw a little picture here.
So it's kind of like you're trying to section of it.
1 would be 0,
Yeah.
2, 3.
Yeah.
I did kind of. So yeah, okay, in terms of, we're just looking at this little section. Yeah, that's all we're looking at is between there and there. And you can't say what is the slope because the slope constantly changes because it's curved. Does that make sense? On a curve, like if I draw it like this, it's easy to see. The slope down here is like this, but when we get up here, it's way steeper, isn't it? The slope is steepness. So slopes of curves changes as you move. Does that make sense? So we're just trying to find the average slope between 1 and 3. Well then, yeah, we just do rise over run. Change in y over change in x. Right? Can you do that? I didn't put the y values on purpose. You can figure it out.
And the table.
No, just in your head.
Just plug in the number.
Yeah. Obviously the bottom. So what are you doing? How do you get the first y coordinate? Just plug in 3. Isn't that it? Isn't it just plugging in 3? Oh, one, oh, did you plug in 1 first?
Yeah.
So you're gonna have
0.
1 minus 3 on bottom? Okay, we can do it that way. It doesn't matter, right? It doesn't matter which one you do first as long as you're consistent. So 1 minus 3. So if I plug in 1, 1 minus 1 is 0, minus, if you plug in 3, what do you get?
24.
24. 3 to the third is 27 minus 3, right? So we get negative 24 over negative 2, which is 12. So the average slope of that would be 12. That's like average speed.
So to find y's, you plug in the x's.
Yes. That's pretty much true, like,
All the
since
time.
forever, yes.
Plug in 1.
Plug in 1. 1 to the third minus 1. The other way we could have written this, we could have gone f of 3 minus f of 1 over 3 minus 1. Doesn't that kind of look like what we did before? F of 3 just means plug in 3. Well, I switched the order. That doesn't matter. Plug in 3, plug in 1, you get 24 minus 0 over 3 minus 1, you get the same thing, right? That's average rate of change. But guess what we're going to do now? We're going to find, maybe I don't want the average rate of, rate of change is just like slope, right? Same thing, you understand that? It's like how it's changing. Slope is rise over run, rate of change, rise over run. Maybe I don't want the average, I want to know what is the slope exactly when this thing is 2. Kind of like before where it was, I don't want to know your average speed from here to, where did we go, Taco Bell or McDonald's?
Taco Bell.
I always get confused. I don't want to know your average speed from here to Taco Bell. I want to know your speed exactly when you were going over the bridge on the Vancouver, right? And that's when we did some. What do you remember? What we did? Do you remember what happened?
Yes-ish.
Yeah, I have an idea, but
Super close numbers on either side of it.
Yeah,
Yeah.
we're like, well, we have to have, in order to find speed, we need like a period of time. We need an elapsed time. But if we made that as small as we possibly could, then it would give us really
Pretty damn close.
Okay. So that whole idea is going to come back here.
so what would you?
I mean, we're going to use a different example though. So we're going to go something like this. We're going to go just a regular old parabola. That way it's easy to draw. We're going to say find the slope when x equals 2. Oops, forgot one part.
The graph.
Forgot a definition over here. If you were to draw a line through these 2 points, a line through 2 points on a curve that has a name, it's called the secant, a secant line.
I was gonna say we went over this.
We've talked about a secant line?
Yeah.
Yeah.
I don't remember.
Way back when.
Yeah, I don't
The
remember.
word sounds
If you have, it's just, all that means is it's a line that goes through 2 points on a curve. So if you had a curve and then a line, that doesn't look like a line. But a straight line that goes through 2 points on a curve, it's called a secant line. So basically what we did is we found the slope of that secant line through those 2 points. I had to give you that because I'm going to start using that word here, I think. I hate when it's on video because then like you can watch it and then you're like, you never use that word. I don't like being on video. So if I say stupid stuff, it's there forever.
Unless you delete it.
the entire world.
Yeah, for all of those 3
Like, you
views.
know when math teacher from Morgan, he's such an idiot.
I know, I'm just waiting for the day some like random person finds my channel and starts watching it and just starts picking me.
I don't see how people watch your kids.
It'll just be some guy sitting there.
Okay.
So there we got y equals x.
Oh, yeah, okay, cool.
Good old parabola. We're going to find the slope when x equals 2. Thanks. The one we just did, we had an interval, right, that we found the slope over, because we had 2 points and we were able to find the average slope between those 2 points. Do we have that here?
No.
No, we just have 1 point. Okay.
You're finding the slope with that single point.
That single point. The whole idea is when this curve goes through that point, if like, imagine you could like zoom way, way, way in, just for that split second, it's got some kind of slope. If you zoomed in far enough, it would almost look like a straight line. And it's got a slope right at that single point. If you go to 2.01, it's going to change a little bit more, right? Because as it curves, it gets steeper and steeper. We just want that single
Your
point.
video should be of you, like, teaching
Doing
me
all my little
drawing a
hand
wing.
things. Maybe that's why you don't learn from my videos, because you don't see me like, okay.
Yeah, we don't get it.
All my facial expressions. So we're still gonna, we can't do slope without 2 points. We need to change in y over change in x. That's okay. So what we're gonna do is we're just gonna pick another point somewhere along here.
She picked 3.
That's not 3. That's just, that's random. So this is the point 2, 4. How did I know before?
Because 2.
I plugged it in, yeah. We're going to call this point, we're just going to, it's just random, it's not necessarily 3, it's just some point a little further to the right of 2, so we're going to call it 2 plus h, where h is just some amount. Okay, I don't know what it is. So if this is 2 plus h, what is the y coordinate of that?
4 plus h.
No.
Nope. 2 h squared.
Nope. Do you know what they're do? How did you know that was 4?
Squared it. Oh,
Plug
2h.
2 in.
2 plus h squared.
2 plus h squared, yeah. Not 2 plus h squared. 2 plus h
Squared.
Yeah. Video person, I was doing parentheses with my hands. 2 plus h squared would be that one, right?
Okay, that makes sense.
Now can we find the slope of the secant line through those 2 points? It's hard to draw a straight line through those without.
It's also like walkie-talkie.
Just
You
draw.
guys are so weird. Why do you send videos from It's the weirdest thing. Life. So funny. I don't know how to
So we're going to find the slope of that line through those 2 points. We can do that, right?
Yeah.
Change in y over change in x, right? That's how you find slope. So change in y over change in x. Does anyone have a guess as to where we're going with this? What's going to happen?
Yeah, you're gonna get an h in there.
You're going to have an h in there, okay. And h is just some distance past 2. So what do we want h to be if we want?
Closest to 2. 2.01.
We want h to be really,
Zero.
really, really small. So can you explain how do we make h really, 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 really small?
0.000001.
Using your language that you've learned, the new thing, the whole
Limit.
the limit as
X approaches 2. Y approaches
h
2. H approaches
approaches
2.
not 2, because that would be 2 plus 2.
2.01.
Okay.
2 plus 0.
We'll come back. We'll come back. Let's just do our slope here. Change in y over change. Let's just see if you change in y over change in x. So
Zero.
y minus y over x minus x, right?
Yeah,
Yeah.
2 plus h squared.
So we're going to take 2 plus
Minus 4.
h squared minus
So you're gonna have 4 plus h squared.
4
4 minus 4
Over?
h squared.
2 plus
It's gonna be
h
1.
minus
2.
2. Oh, are you telling me that 2 plus h squared is 4 plus h squared?
No, freaking h in there.
Frickin' A, yeah, exactly.
I don't know how to do that.
Heidi, what's 2 plus h squared?
Isn't it? It's a really long. Like,
It's not really long.
I have to like set it.
Yeah,
up.
it's
Do it, do it,
Four-
okay, do it.
4
Multiply
plus
it out.
4h plus h
Simplify
squared.
that. Just don't do 4 plus h squared, because that's not correct. Write them next to each other, distributed property, get your answer.
H
Combine like
squared
terms.
plus 2h plus 4. Is it 4
Combine like terms, get it as simplified down as possible.
h squared plus 4h plus h squared?
Yeah, and then
Yeah.
you
H
end
squared
up
plus 4.
four
But
minus
there's a-
4 is 0.
There's still more you can do. Keep going. There's
So can you do 2 minus, you could do 2 minus 2 on the bottom?
And 4 minus 4 on the top?
Yes.
combine
So
like
you have
terms. That's combine like
H.
terms.
So you have 3h plus h squared on top by itself.
H squared plus 4h.
You end up with 2 plus h minus 4 on the top and just 2 on the bottom, right?
You can keep going. Factor the top once you get down to a certain point and divide. Your fraction will go away and you'll have just.
H plus 4.
There it is.
Yeah.
H
Wait.
plus 4.
Oh, I took it away from the 4h instead of the h squared. My bad.
Because right, we got this
4h plus
was.
h.
I don't know. Did you write 4 plus 8?
H plus 4.
So 8 squared plus 4h plus 4 minus 4 over 2 plus h minus 2. Or like that. Or you might have put 4 plus 4h plus whatever, same thing.
So you have h.
4 minus 4 is 0,
plus
2
h,
minus
and
2 is 0.
have
So you have h squared plus 4. H squared plus 4h over h.
Divide the h's.
Can you divide out?
Factor the top.
Factor the top.
Or just
Or just
divide
divide
by
out an
h.
h. Same
I don't have to divide
idea.
by each.
This would be h plus times
4.
h plus 4 over h. h's are gone. So you have h plus 4.
H is such a weird word.
H.
This is a weird word. So that's the slope of our secant line. Right there, h plus 4. That's the slope of that line. So that just depends on what h is, right?
Yeah.
If we make h big, this will get bigger. But if we, what do we want h to be?
2.0001.
0.000000000. So, like I said, using the language we've learned in this class, how would you say, I want to make h get as small as possible?
Limit is
H approaches.
We're going to do the limit as h approaches 0,
Wait, why 0? I thought we wanted 2.
Oh, this point.
because h is the
Oh, because we're going.
added on to 2.
Yeah, yeah, yeah. Okay.
H is the distance this point is away from this point. So if I can bring this point down, imagine this point going along the parabola, I want to move this point as close as possible to that point, right? Isn't that the limit as h approaches 0? We want that distance. Here's this point, can't see this on the video.
So technically, see, exactly. So the point technically is like 0.
You got this point, you got this point. The closer this point gets to here, the closer our slope will be to the slope of that single point, right? So we're just taking this guy and we're moving him as close as we possibly can to this guy. And the h is just the distance they are away from each other on the x-axis. So as this gets really, really close to 0, isn't that getting really, really close to the slope at that single point?
Because you're like taking it to a distance where it's like starting at 0, right? Like that would be the distance at 0, 1.
What?
Like
2 would be 0.
2 would be, yeah, 2.
Yeah,
That
when
point would
h
be-
is 0, that's 2.
Okay.
Yeah. So we're doing but we can't just plug in 0 for it because then
Maybe
we
you
only
have
have
two.
1 point.
Yeah.
So we're doing the limit as this
it
gets
closer.
close to that.
Just reveal the man behind the camera.
What?
Everyone knows who you are now.
You reveal the man behind the camera.
Oh.
He should start with like a selfie. And
Yeah.
So we're doing the limit of h approaches 4 of h plus 4. Or h approaches 0 of h plus 4, which is
2.00000001.
2.
0.00001.
oh, no. What's the limit as h approaches 0 of h plus 4?
2.
0.
4.
What do you think?
Wait.
4.
Is it 4?
It's 4.
Oh, you plug in 0.
Zero.
Oh.
That's the slope of.
Oh.
What would that line be called? Do you know?
The.
I'm going to zoom in right here. So you've got a parabola like this. There's the point 2, 4. I said a line that goes through 2 points on a curve is called a secant line. Does our new line go through 2 points of this curve?
Cosecant.
Good guess, but no. It doesn't go through 2 points, does it? It just touches it at 1 point.
Did we go over
The
the
tangent
circles?
line.
It's the tangent
Yeah,
line.
there you
Yep.
go.
Oh, we just wrote that on the top.
Oh, yeah.
Oh, yeah. Rates of change and tangent lines. That's a tangent line. Slope of the tangent.
That's actually the only reason I said tangent.
Yeah, if you're tangent to a curve, it just means the line just skims it and touches it at that 1 point. So not only can we find the slope of the tangent line, but we can find the equation of the tangent line. We know the slope, don't we?
4.
4.
She said.
Do we know a point that it goes through?
Yeah, 2, 4.
2, 4. So can you tell me the equation of the tangent line?
4x plus 4 for h.
Nope.
2.
This is why we did chapter 1 first.
Repeat, please.
I want the equation of the tangent line.
Which would be x, what is the?
Can you find the equation of the line?
ax
Okay,
plus
do you know the
b.
y-intercept, Bill? So is there an easier way besides y equals mx plus b?
Oh, mx would be go.
Remember point slope form?
Yeah.
Oh, yeah, the,
Y minus y equals slope and x minus x?
I don't remember that. Is there a K in there?
no, that was graph.
Remember that?
I don't.
Yes.
honestly.
No?
X minus, x1 minus x2.
Okay, well if you don't remember that, you can do y equals mx plus b.
Oh, X1.
Or y1 minus x2 minus x1 minus x2.
You can do this. Do you know the slope?
Yeah, 4x. Plus,
You know, you don't know the y-intercept, but
0.
you know a point, don't you?
yeah, 2. So plug in 2 and 4.
4 equals 4 times.
So 8 minus 8 is negative 2.
4 equals 8.
I got negative
plus 8 minus 8, so
Oh,
9
that's right.
minus 8, negative 4 equals b. Y equals 4x minus 4.
That's the equation of that line. Easier would have just been point slope form. Y minus y equals slope x minus x. That's also a perfectly acceptable answer.
I like the other one.
You could simplify that down to this, right? Remember that?
I don't remember that anymore.
Distributive property. Add 4. Hey, what do we get? Same thing. It's just that's point slope form, that's slope intercept form. So there's the equation of our tangent line. This is like groundbreaking stuff if this was 1629, the year 1629.
I figured this
Oh,
out.
what we just
then.
did, if you could get in a time machine and go back to like January of 1629, you would be like the coolest person on the planet if you could show them this. It talks about it in our book.
I'm glad you're going to read the book.
Like page 88 says, why do we find tangent to curves? This is useful. This is not just math. This like has application to stuff. It says in mechanics, the tangent determines the direction of a body's motion at every point along its path. You want to do engineering? This is great stuff right here. So if you're talking about a particle moving along a path, it's the direction in which it's moving along a curve.
Nurse, man.
In geometry, the tangents of two curves at a point of intersection determine the angle at which the curves intersect.
Oh, I
So
would.
you could have two curves intersecting and determine the angle at what they intersect by using the tangent line. In optics, you know what optics are? Vision, glasses, telescopes. It says the tangent determines the angle at which a ray of light enters a curved lens. The problem of how to find the tangent to a curve became a dominant mathematical problem of the early 17th century, and it is hard to overestimate how badly they wanted to know the answer. People wanted to know the answer, so they could do this.
Do you do the Coca-Cola one? No. I did that one yesterday. So proud of myself.
What?
Are you going,
Not done.
are you going to home for lunch?
We're going to talk about Dick Hart. He's a cool guy.
Can I drive home so I can eat at lunch then?
No, I'm going to the store.
It's fun.
You don't even have your
on
license, you
YouTube.
can't drive.
I know.
No cops at lunchtime.
I don't care.
What are you gonna talk
Says
about?
Descartes went as far as to say that this problem was the most useful and most general problem, not only that he knew, but that he had any desire to know. And he was
Oh.
learning.
So, okay, right here.
It's like a guy's whole life. Like, seriously, it was. Because of how useful it was and the stuff he was trying to figure out back in the day.
Are you just gonna give us homework now, or are we still working on this stuff?
Give you homework, but
So we can do it?
you only have to do this twice.
What's the other stuff on what we've been learning before?
No. Quick review, 1 through 5. Number 3, 5, 10, 12. Oh, I guess just notes. At 12, you just have to do A and B.
Right here.
Quick review 1 through 5. That's just review of
Slope.
linear equations and slope. 3, 5, and 7, or 3 and 5, average rate of change. So it's just change in y over change in x. Plug in the points. It gives you the interval, it gives you the x's.
I like it.
There's an a and b to both of them. Okay. I'm going to be a little more hardcore tomorrow when I look at your homework. I'm imagining a few more 6s than normal. Because if it's not done and everything's not done, then it's going to be a 6.
Do we have to write out the problem? Like, in the book problem?
It's just the same.
Like, do I have to write the point -5, comma 2, 3, comma 5, and then do it? Or can I just do it?
Oh, you should, I mean, how's, yeah, okay, sure.
Brenna writes out every single
I write out
problem.
every problem.
Good. Number 7, no, because there's a bunch of words. Estimate the slopes of the
Oh no, I
secants.
don't do that.
write,
I
oh,
don't do
okay.
that. I do like if it's.
But yeah, if you're going to
F of
find the
X
slope of
equals-
something, you go A, B, and
Or the limit.
Well, I just look at it and then do
something
it.
like that.
look at 7. The directions are actually up above it. So don't tell me I didn't know what to do on 7.
Okay. Can I go to my class because she'll do it tomorrow?
Dang, you got me.
What the heck, 3 minus b over 1 minus a?
Can I do it?
On 7 it says, estimate the slopes of the secant lines PQ1, PQ2, and PQ3, and PQ4. So it's all about estimating slopes.
Am I on the wrong thing too?
2.4,
Yeah. Oh, estimate the slopes, okay.
number 7, I told you the directions are above it.
Yes.
Okay.
It says in exercises 7 and 8, do A and B. I'm just having you do 7. It's about Rawls' car accelerating from a standstill.
How weird.
So how would you do that?
So you're estimating, like,
The point over a point?
PQ4, what would be the approximate slope through those 2 points? The reason it says estimating is because look at
Oh, I get
Q4.
it. P through Q.
You don't know if
okay.
that's
So you do P with each one of those,
Yeah.
the difference? Okay.
the slope through those 2 points. A Q4, it just says estimate because you don't know. It looks like about 550.
Look at number 2 on quick review. That's retarded.
And then 12, that's where you got to do this. But you're going to have to do it without a graph, unless you draw yourself a picture, but there is no picture.
Can't
Which
you?
we really didn't need the picture. You just need your 2 points. So you can do change in y over change in x.
How do you find your 2 points?
It says at x equals 0. So to get the y coordinate of that point,
Plug in 0.
plug in 0 for x. So that would be your 1 point. You'll have 0 comma something. Then your other point will be 0 plus h, comma, and then plug
Oh,
it in.
that's stupid.
It's going to be tough. Let me set up 12.
Both years, I can put 15. Oh no, my sophomore year, I was an A. I passed last year and the year before that was an A too, but I'm freshman year, C plus.
So if you're trying to find the slope, or you're trying to do what we just did here, your 2 points, your 1 point's going to be 0 comma what? Oops.
-1.
It's negative 1 actually, yeah. Too fast. So your other point though, your point a little farther up the curve is going to be what?
0 plus h and then 0 plus h squared.
H, and no, not 0 plus h squared.
Oh,
but
0 plus h
0
squared
plus
minus
h
3.
squared minus 3 times 0 plus h minus 1.
Oh, because you plug it in for x.
You gotta
Okay.
plug your x coordinate into the equation. So then you're gonna have to do change in y minus y over x minus x, and do a bunch of distributive property and combining like terms and
That does
simplifying
not sound like fun.
all the way down to where you get something, and then take the limit as h approaches 0 of that something, and then you'll have the slope.
Then with the answer you put into the y equals on the.
Then,
first
yeah,
figure,
that's part B.
then it will-
The first part's just the slope,
Oh, okay.
and then part B, the equation, that's where you have to plug it in to get. You could do y equals mx plus b, or just do this, easy, just faster. Y minus y.
0
and then
plus
x
h
minus x.
looks like OTH, which reminds me of like,